Hello, I am David E. Barker. This is Programming Today I Learned. Today we're going to be looking at Svelte again. We're going to be looking at why and how we use local storage versus session storage versus cookies in storing our JWT and how we can get around security issues with that. Um, Before we dive in, let me just mention I have a Patreon. I would love it if you would provide support for future episodes. That would be fantastic. You'll find the link down below. I also have a newsletter on programmingtil.com. Sign up for that, and you'll get information on the latest episodes. Okay, without further ado, let's go ahead and dig into code. Take a look at what we got. So the first thing is, on our backend, why aren't we using cookies? And why are we using local storage for our JWT? So let's go ahead and take a look. We have a thread here on device JWT that discusses it. There's a little bit of TLDR, but we'll go look at the thread in a minute too. You can't use different domains. Long term, we want to use the same API for our mobile app, which may not have access to cookies, things like that. And we're using an AUD, which is going to provide the client information. And so that way we know who the client is. Of course, the biggest concern is cross-site scripting, and that's why people say don't use local storage for JWT tokens. Let's go ahead and look at that thread, and then we can look at our application and some of the changes that we've made. So in JT 1982 here, Nicholas Thompson writes, I should said, seen suggested I should trust a cookie with my JWT. Local storage is not recommended as a serial location because it's accessible under an XSS attacks, which are cross-site scripting. Ideally, an HTTP cookie can be set. Is it possible to configure device JWT in this way? And that makes total sense. I talked about this. We had a discussion thread, but it was very brief, of why we're going to use local storage in our case and how do we alleviate problems. And Mark, who created Devise JWT, says this, and this is a problem, which is not a problem, but security measure with cookies, is they can't be shared cross-domain. So you're creating an API, you want multiple consumers of it from different places. Well, with cookies, you can't do that now. So that suddenly just defeats the purpose of this API that you're having. If your client and server live in different domains or servers, you're stuck with headers, params, request, body, or client server communication. If they live in the same domain, then you can use cookies for everything, including authentication, so you don't need a token-based authentication at all. Again, it's worth repeating, you don't need token-based authentication if everything's on the same domain. Just use cookies. Even if you have to send the token to the server through the headers request, the client can store it in a cookie inside local storage. So that's really up to the client how you want to store it. So we're going to continue to persist this within local storage, and I'll show you why it still is safe in a moment. In the meantime, let's go ahead and just take a look at some of the changes we've done. First thing is we have our sign in, and it's going to redirect now. It's just going to use a simple go to. And if we update things here, it's going to go ahead and just work. If we refresh this page, it's going to work instead of showing that error that it had last time. We're no longer storing our AUD on the local storage, just the JWT. And I'll show you why that's important in just a moment for security's sake. And then when we sign out, we're going to route to the homepage as well. So let's go ahead and take a look at our code changes. First thing is, within our package, I have installed crypto.js. So that's something we're going to be using in a moment. Let's go ahead and take a look at our nav. In here, we went ahead and put the go-to. So after you've signed in or signed out, we're going to go to the homepage. And that's the only real change here. Close these out, respectively. And then in settings, we have this, we added the go-to. We have our AUD has been added to our store. And we've imported on-mount Svelte, which we used previously. We're now defaulting these to undefined. And then when we mount them, which means we know we have made the user request or access to the user inside of our template, we have access to this user. Then we can go ahead and set the user's display name, email, and username respectively within the form. And then down here in our submit, we're going to make sure we pass the value of the AUD which is stored in this Svelte store. And then we still set the same thing on here, but and then if we have an error, we go ahead and go to the home page. Layout we'll come back to in just a moment. Sign in. And actually look at the stores. We just added a few writable stores that have a default value of unknown. We have our AUD, we have our browser, our IP address, and our operating system. So what we want to do is, when we're first loading the applications, we're over here in layout, we have on mount from Svelte, we have this new AUD builder and browser detector from shared helpers, which I'll show in a moment. We have the stores of AUD, browser, and OS. And when we're mounting, so this is a layout, so this will happen earlier. If we're in the actual browser, we're going to get the version of the browser, and then we're going to go ahead and pass this to the AUD builder. I don't think I need that comment there anymore. And we're going to set our AUD. Then from our browser detector, we're going to go ahead and set our browser name and version with 2 pipes to delimit the name and the version, as well as our operating system name and version. Then when we go ahead and sign in, you'll see we have AUD, browser, IP, and OS added to our stores. We're going to use this free service here, jsonip.com, and it's going to go ahead and set the IP address. If it fails, we don't care, so that we're going to put this in a try-catch block. IP is not a necessity within our application. We're going to go ahead and pass our user along with our browser, IP, and OS. And then we're going to pass the AUD, which will be set in the AUD header within our APIs. So if you look at our API JS here, and this is all done previously, you'll remember this is the JWT header that our Rails application expects. So let's take a look at how we get this value. Oh, and then we sign in, we set this code too. How we get this value, which is provided within our layout via the browser detector as well as our AUD builder. So first, browser detector, as it says, gets in browser information, native technology. Here is the blog post that I pulled this from. So you can see what this guy's code looks like. I'm not going to walk through this guy's entire article, but basically it provides various information about your browser as well as your operating system. So go ahead and you can walk through his code, but basically it takes information and lets you know what the OS is, what the browser is, and what version. And if I found it to be very nice for very simple things like this. We're going to take that browser information in and put it into our AUD builder here. Now, this is, as I mentioned in the Rails one, this is kind of a security through obscurity thing. This being said, I will go into why the AUD works better in just a second. First of all, we're going to parse out the integer version of the browser version. Then we're going to construct a string, and we're going to use crypto.js to take a SHA-256 of this string. And we'll be passing that. That will be our AUD. So that's going to be the defining what is this JWT tied to this AUD? What is this a valid JWT token? The way the AUD works is when you have a JWT, it has to have a corresponding matching AUD. If it doesn't, it rejects it. So while a person may steal, if you have an XSS issue 1, and then somebody may steal the token 2, they still don't have access. The token is useless without the proper AUD. If they just steal the SHA value of it, they won't have access to it. They can brute strength through all operating system names, version, browsers, and browser versions, And I could probably do the minor version here too, which would make this even more iterations to browse through rather than the major version. Um, but that is a lot of brute forcing in order to determine the right AUD to match to the JWT. So between that and then making sure that your tokens expire at a reasonable time will allow the user to not really have to worry about just the JWT token being stored in the local storage. If you don't agree with this method, or haven't used AUDs, leave a comment below. Let's discuss, what you think we could do to be a little bit better, especially given our requirements that we need to be able to use this within multiple applications on different APIs, different sites, and our mobile app, which won't have access to cookies. So a lot of interesting things to deal with there. If you haven't checked the Rails application version in the last episode, we ended up doing some comparisons for this signing in token to ensure that the browser OS, IP, etc., builds out and matches the AUD. Again, that's the security to obscurity part. But in general, the AUD itself is going to be something that is only stored within our Svelte store. It's not stored anywhere locally, and it's created on the fly when the user opens their browser. So it's not something that's easily accessible from somebody else's application. So that's it for this episode. Like and subscribe if you would. I would love it. Support it on Patreon so we can make more great episodes as we continue to build out this application. And sign up for the newsletter. Thank you so much. Talk to you later. Bye.